back to the grind officially. We're back to Euclidean geometry. We're back with contending with it. Well, we're not really contending with it, but we are taking decisive action to seriously master this topic in mathematics, right? We are no longer going to lose 30 marks just because of Euclidean. Let's get into it, okay? So here we have question 8 over here. O is the center of the circle. Radius r and chord AB equals to the square root of 128 centimeters. OCD is perpendicular to AB. OC to CD is 3 to 2, and then ABD is 27 degrees. Now, the reason why I have this little banner in the video is because if they've mentioned anything about there being a center, you need to list all the theorems in Euclidean geometry that regards the center, right? So we can clearly see that OD is a radius. OD is a radius. Why is that? Because the radius is a line that stems from the center to the circumference of the circle, okay? When a line is perpendicular to another line, that line that's perpendicular to bisects that line into two equal parts, meaning it's perpendicular to it, okay? OCD is perpendicular to AB, meaning that the point of intersection, which is there by C, the point of bisection, which is C, is going to equal to 90 degrees. And it's going to, and it also bisects that chord AB into two equal parts, okay? So now we're taking it off step by step. So now another part of another Euclidean theorem regarding the center of the circle is angle at center twice as much as angle at circumference. So we first have to make sure that it's actually applicable to this specific diagram. Now, the only way, a lot of students think that they just look for this little bow tie shape, this kind of skewed bow tie, and they think, okay, yeah, now I can actually use angle at center twice as much as angle at circumference, and that's not the case. What you need to do is you need to look for the arc. You need to look for a common arc, an arc that subtends both the center and the angle at the circumference, and I'm explaining exactly what that means, right? The very first thing you have to do is you have to draw a line from the center to the circumference, right? But over here we can clearly see that bow tie shape, but that's just not an effective way or effective strategy to determine if you can use angle at center twice as much as angle circumference. You need to identify the arc that subtends O, so that's AD. Draw a line from the circumference to the center of the circle, it ends over there. Draw a line from the center circumference of the circle, it ends over there. So that means they're both subtended by arc AD, meaning that angle twice as much as angle at circumference will be applicable to both O and B because they're both subtended by the exact same arc. Okay, so you have to remember that. Very, very important. And please rewind that part over there and just see exactly how I identify the arc that they're both subtended by, okay? So that means that O is going to equal to 54 degrees because I multiplied 2 with 27 degrees. O is twice as much the size as B. Now, we can also join in a radius in for ourselves, guys. That's another one that's a part of our list. OB is a radius. And we don't have any diameters. So just look, a diameter is a line that cuts through both ends of the circumference of the circle while going through the center. A radius needs to be made up of two radii, and we don't have that in this question, right? So that's very important. So I'm just going to pick out another color over here. And now we have to remember that 3 to 2 is the ratio. OC to C2 is the ratio. It's not the size. There's a difference between size and ratio. Ratio is basically describes how much larger another part of a geometric sequence is compared to another. Okay, so that's important to remember. Anyway, so I've labeled it out, guys. The square root of 128 degrees is 4 multiplied by the square root of 2. And please note that the AB is a chord, but it was split into two equal parts. So if it was split into two equal parts, you need to divide the square root of 128 with 2 by 2, okay? That's important to remember. The very first thing is you want to write out the ratio. OC over CD equals 2, 3 over 2. The reason why we multiply it by 3 is because, by the way, OD is the radius, not OC. Remember, so a radius is the line that stems from the center to the circumference of the circle. Okay, so that's important to remember, very important to remember. So you can clearly see that OC is 3R. Okay, it's 3R, but it's not the radius, okay? So remember, OD is equal to 5R, actually. So OD is equal to 5R. OC, and obviously, since OD equals to OC plus CD, you're going to have to take 3R plus 2R. So because that gives us OD. The reason why OD is 5R because they told us to label all the radii as R, and we're looking for OC. So we want to include OC into our calculation. And remember, guys, OC just makes up a part. It forms a part of the line. Okay, OC is equal to 3 to 2, so it takes up 3 parts of the line, right? It consists of 3 parts of the line. It's 3 parts of the line, right? So, and then the entire line is 5 units, so that's going to be 3 over 5. Okay, so that's why we said over here 3, we have AC which equals to CB, right? So if you want to calculate what R is equal to, guys, we need to use Pythagoras, because R is a unknown variable and it's a part of a 90-degree triangle. Anytime we see any angle that's a part of a 90-degree triangle, what do we think of? We always think of Pythagoras, right? So in Pythagoras, you need to take the largest side, which is R, and take to the power of 2. OC is 3 over 5 R, so you have to take that to the power of 2 because that's part of that Pythagoras. Okay, so I'm just going to write that out. R squared. So you need to take 3 to, be very careful, guys. Take 3 to the power of 2. What's 3 to the power of 2? Don't just say 3 over 5 R squared. That's wrong. 3 to the power of 2 is 9. And then 5 to the power of 2 is 25, right? So you just need to take both sides, both numbers to the power of 2. And then R to the power of 2 is R squared. Plus, okay, what is 4 multiplied by the square root of 2 to the power of 2? It's 32. Then we still have R squared. Now we're going to take 9 over 25 R squared over to the other side because they're like terms. They both have R squared. That's going to give us an answer of 16 over 25 R squared equals to 32. You're going to cross multiply, and that gives us an answer of 100, which equals to 16 R squared divided square rooted. Then you're going to get an answer of 5 multiplied by 2 centimeters. 5 multiplied by the square root of 2 centimeters. Now for the last answer, 8.1.2, calculate the with reason AOD. So remember, we calculated that previously. AOD is equal to 54 degrees because of angle at center twice as much as angle at circumference.